GPRS protocol architecture. Now here figure shows the protocol architecture of the transmission plane for GPRS. All data within the GPRS backbone, that is between the GPRS support node, is transferred using the GPRS tunneling protocol, that is GTP. GTP is the GPRS tunneling protocol. GTP can use two different transport protocol, either the reliable TCP needed for reliable transfer of X.25 packets, or the non-reliable UDP used for IP packets. The network protocol for the GPRS backbone is IP, using any lower layers. And to adapt to the different characteristics of the underlying network, the sub-network dependent convergence protocol, in short we are calling them as a SNTCP. SNTCP is used between the SGSN and the mobile station MS. On top of the SNTCP and GTP, user packet data is tunneled from the mobile station to the GGSN and vice versa. To achieve a high reliability of packet transfer between SGSN and mobile station, a special LLC is used which has ARQ, authentication request, and FEC mechanism for point to point and later on point to multicast services or PTM services. A base station subsystem GPRS protocol, in short BSS, base station subsystem GPRS protocol GP, is used to convey the routing and quality of service related information between the base station subsystem and SGSN. BSS GP does not perform error correction and works on top of the frame relay network, or work on the FR network, frame relay network. Finally, radio link dependent protocol are needed to transfer data over the UM interface. So the radio link protocol RLC provide the reliable link, while the MAC control, medium access control, with signaling procedures for the radio channels and the mapping of LLC frames onto the GSM physical channels. The radio interface at UM, which is needed for GPRS, does not require the fundamental changes compared to the standard GSM. However, the several new logical channels and their mapping onto the physical resources have been defined. For example, one mobile station can allocate up to packet data traffic channels. So in short, we are calling them as a PDTCH. So capacity can be allocated on demand and shared between the circuit switch channels and the GPRS. So this allocation can be done dynamically with load supervision or alternatively, and the capacity can be pre-allocated. So this is about the GPRS protocol architecture. Next part is the GPRS applications. So mainly the GPRS is used in mobility, Mobility means the ability to maintain the constant voice and data communication while on the movement. So sometimes the mobile device MS is moving from one location to the another location. So in that case, we need to maintain the quality of voice and data communication between the GPRS and mobile station. So this is the first application, mobility. Second, allows the user to obtain the connectivity when needed. So regardless of the location and without the lengthy login sessions, right? And third application of the GPRS is the localization. So allows all the users or subscriber to obtain the information relevant to their current locations, right? So this is called as a localization related applications, or we are allowing the subscriber or users to get the information or to obtain the information related with the location. The GPRS benefits the user in many ways, right? So here we discussed only three: mobility and connectivity and localization, right? So one of which is the higher data rate in terms of the shorter access time, right? So this is about the GPRS applications. Limitations of the GPRS is limited cell capacity for all users. GPRS does not, sorry, GPRS does impact a network existing cell capacity. So there are only limited radio resources that can be deployed for different uses. Speeds much lower in reality. So if you consider theoretically the maximum GPRS data transmission speed is 172.2 kilobit per second. So it requires a single user taking over all 8 time slots without any error protections. Transmit delays. GPRS packets are sent in all different directions to reach the same destination. So this opens up the potential for one or some of those packets to be lost or corrupted during the data transmission over the radio link, right? So these are the limitations of the GPRS. Thank you.
Hopefully you might have enjoyed the lecture. Then please do like the video and know your thoughts in comments. Please do share this video among your friends and don't forget to subscribe to our channel. After subscription you can press the bell icon to never miss the notification regarding our new videos. Thank you so much.